Hello guys, welcome to my next class. We already discussed few problems based on linear transformation, how to find out the rank, range, nullity, range space, null space, these things, and also we verified rank nullity theorem. Now here they given one different problem, continuation of that previous classes. Find the linear transformation. Here they are not defined any function. I want to find out for what function we get this type of images. They are not asking to find out range space, null space, rank, nullity. They want to find out linear transformation for t is mapping from 3-dimensional to 3 dimensions over a set of real numbers. Suppose the images is spanned. These are the images of that. Now these are the images means these are belongs to where in V3 of R. It means codomain. But you know that they are not mentioned any ordered base for the domain or codomain is possible to take in terms of the standard vectors or standard basis. Therefore, now they given already image, but then I have to write the what are the standard basis here. Now here I want to find out image. Now we see they given already image. Now I am going to imagine these are the image based on the standard vectors of V3 of R, because you know that all the dimensions, either maybe 2 or 3 or 4 or n dimensional or standard vectors form a basis. Therefore, confidently what we are going to assume that I am going to take what are the standard vectors. The standard vectors, please try to understand, only the possibility they given already image, I am going to assume these are the image for the corresponding standard vectors of domain. Vectors of V3R. V3 of R are what actually 1, 0, 0, 0, 1, 0, 0, 0, 1. Then T of 1, 0, 0, no need I to find out. We can't find out also because they are not given a function. What's the image? 1, 1, 0. What is T of 0, 1, 0 here? What's the second image they given? 0, 0, 1, 1. Similarly, 0, 0, 1. Please try to understand. I am assuming these are the image of the standard vectors of domain. Now that is that 1, 2, 1. Because there is no other alternative. You can't take simply all the vectors or form a basis. You have to choose a vectors that must be form a relative basis for domain. Okay. After that, what we are going to do, now we have an image. Therefore, now I am going to choose one of the vectors. Say, let x, see it's a mapping 3-dimensional to 3-dimensional. Let x, y, z belongs to V3 of R. Now, I want to find out image of this. See, please try to understand. X, y, z is belongs to where? In V3 of R. What's the order basis for the V3 of R is 1, 0, 0, 0, 1, 0, 0, 0, 1. These are the ordered basis of V3R. Means I explained so many times in the previous classes for linear representation matrix for the linear transformation. I choose any vector in the ordered basis vector space. That vector can be written as linear combination of vectors of the ordered basis. Now I am going to express the xyz in the form of x into, suppose I have to take this is E1, this is E2, this is E3. Now that's the thing. Otherwise, these three vectors are not a ordered basis of what about that domain. Therefore, from the definition of ordered basis of the vector space, I choose any vector in the vector space that can be written as linear combination of the vectors of the ordered basis. Therefore, x into E1 plus x into E2 plus x into E3. Instead of this, I am considering E1, E2, E3. Take linear transformation, because T is a linear transformation. I am going to take T on both the sides. What do we get here? T of x into E1 plus x, sorry, it's not x actually, x, y, z. Y, E2 and then z, E3. Okay. From the property of, one of the property of linear transformation, the property is T of C1 alpha 1 plus C2 alpha 2 can be written as what actually C1 T of alpha 1 by we already derived this result by using mathematical induction. from that what we get actually x into T of E1, y into T of E2, and then z into T of E3. What is T of E1? What is T of E1? T of E1 is nothing but, we already know that 1, 1, 0. Yeah. What is T of E2? The image is nothing but 0, 1, 1. Yes. What is my T of E3 is 1, 2, 1. Yeah. Simplify that. What we get? X, comma 0, 0, y, and then z, comma 2z, comma z. Now I have to simplify this. What we get actually? Add the first component x plus z, yes, comma, and then add the second component x plus y plus 2z, and then add the third component. What's the third component? 0 plus y plus z. What do we get? Y plus z. This is a linear transformation function. T of x comma y comma z equals x plus y comma x plus y plus 2z plus comma y plus z. Then only we get, based on the standard basis vector, these are the image in V3 of R. Now, they are going to ask us type of problem, how to find out the linear transform. This is a way to find out the function. I think everyone is clear. First you assign the given image to the standard vectors. After that you choose one of the vector. These vectors are order basis of domain. From the definition of order basis, I choose any vector in vector space that can be written as linear combinations of vectors of order basis. And then apply the linear transformation on both sides. Apply the linear property of a linear transformation. Simplify it, and finally we get a function. This is a way to find out what the function, linear transformation function. Now I'm moving to the last problem. It's a fourth problem. That is a little bit different compared to first, second, and third problem. Yeah, the problem is T is mapping from, yeah, please wait 1 minute. I want to clear the board. Yes. Now, fourth problem is T is mapping from V3 of R to V4 of R. V4 R. Okay? Is defined by T of E1 equals 0, 1, 0, 2. E1 means 1, it's a three-dimensional. What are the standard vectors? 1, 0, 0, 0, 1, 0, 0, 0, 1. T of E2 is nothing but 0, 1, 1, 1, 0. T of E3 is nothing but, is mapping three-dimensional to four-dimensional. 0, 1, minus 1 and 4. Find range, null space, rank, and nullity. Also verify nullity of T and verify the rank nullity theorem. No, see, observe, they given already one step, they given already what we solved in the up to 3 problems. First problem, second problem, third problem. They already given what say images of standard basis vectors of V3 of R. T of E1, T of E2, T of E3. Now, here, instead of giving the, in the third problem, they given in the theory, that's why we written T of E1, T of E2, but here they given very clearly. Therefore, first you write the matrix. The matrix of A, the matrix A matrix A of NT. NT means linear transformation. What can give a linear transformation? From that I am going to write a matrix. A is nothing but first row is nothing but first image 0, 1, 0, 2. What's the second row? 0, 1, 1, 0. Then 0, 1, minus 1, 4. You have to observe one thing here very clearly. Number of rows is not equal to number of columns. 3 rows, but the 3 rows and 4 columns. Observe very carefully. In the each of the row, first element must be a 0. Means we are neglecting. In such cases, we are neglecting. What we are telling the students? Always first row, first element must be a non-zero. But here what happened? In each of the row, all 3 rows, common is 0. In such cases, we are telling the students you neglect that column. Where pivotal column, pivotal row, pivotal column is start from second column. Second column itself is a first pivotal column. That's why I am taking this problem. These are the different type of ambiguities are there. See, whenever in all the rows commonly the first entry is 0, what we are going to say to the student, you neglect the column. We treated second column itself is a first pivotal element. Okay, we are not bothered. Suppose first row first element is a 0, the rest of the value in the first entry is non-zero, I have to interchange. But even the interchange there is no use because in every case in each of the first entry of the row must be 0. Then we are saying that we are neglecting, we start from this. Therefore, this is my pivotal element, is a non-zero. Using this, I try to convert the rest of the element must be 0 by using elementary row operation. 0, 1, 0, 2. What we are going to do that? R2 plus minus 1 into R1. Minus 1 into R1. Yes, because these two become 0, 0, 0. Okay, fine. Now here we get 1 minus 2. Okay. Next, what we are getting now here? R3 plus minus 1 into R1 because just subtract we get 0. 0. This is as usual 0. Minus 1, 0. What we get? Minus 1. What we get here actually? This is actually what we get actually. Now I have to multiply by minus sign. What we get actually? 4 minus 2. What is 4 minus 2 is 2. Observe carefully this. Yeah, minus 1, 0. 4 minus 2 we get what actually? 2. Now after that, observe second row. This is second or third element. This is my pivotal element. Next is this pivotal element. Is non-zero. I have to convert the following row value must be 0 by using elementary row operation. Yeah. Fix 0, 1, 0, 2, 0, 0, 1 minus 2. And then I have to apply the row operation. What operation we are going to do? R3 plus R2. What we get actually? Enter the value must be 0. Enter the value must be 0. Now don't stop. This is echelon form. I told number of times you convert into row reduced echelon form. Row reduced, observe. This is row reduced echelon form. Yes. Why is a row reduced echelon form? Observe, this is my pivotal column. In the pivotal column, observe, this is my, please try to understand that. Yeah, remove all the circle here, then otherwise you are going to confuse. See, observe. This is pivotal column, this is pivotal column. Okay. Observe in this pivotal column, except pivotal element, the rest of the values are 0. This is not pivotal column. For second row, only one pivotal. You can't say that third column is also pivotal column. You already know that. Now, that's why what we are telling the student, we are reduced to, I told in the previous problem so many times, number of rows is not equal to number of column. I have to convert in that case before going to take rank or range space. You have to convert which form? Row reduced echelon form. Here, yes, this is a pivotal column, this is except pivotal element, the rest of the values are 0. Therefore, it is converted into row reduced echelon form. This is in the form of what? Row reduced echelon form. And having how many non-zero rows? 2 non-zero rows. 0 rows. Therefore, what is a rank of T is what actually 2, and also R of T. R of T is a subspace. Yes, subspace generated by what actually? What are the vectors? 0, 1, 0, 2 and 0, 0, 1, minus 2. Therefore, what is our what about that range spaces? 0, 1, comma 0, 2 and then 0, 0, 1, minus 2. Therefore, what's the dimension of this range space is 2. We already know that rank of linear transformation is due as dimension of range space. Now, they what your written rank also correct. Next, finding what actually null space. After that, we get relative. Finding n of t. Please try to understand here. 3 dimension is mapping to 4 dimensional. I'll continue in the next class the finding n of t. Okay, thank you very much for listening my talk. Now we have to finding what actually null space. We already found out what actually dimension of RT. What is the finding n of t means? Observe carefully here. Is mapping 3 dimensional to 4 dimensional. Therefore, let choose one of the vector. That vector having how many? What's the dimension is 3 because n of t is a subset of domain. Domain means V3 of R belongs to n of t. From the definition of null space, this is nothing but transfer this what about vector is transformed to what actually 0. Then only say that vector belongs to null space. Now this can also be written as now here we can't apply directly any function because here they are not given any function. They are not given t of x, y, z. It's not given any function t of x, y, z in terms of the 4 components in terms of x, y, z. Okay. Suppose they given, we solved in second problem directly. I am writing it in terms of 4 components. 0 can be written 4 components equal to 0. But you can't do like that. What I am going to do? X, y, z can be written as x into e1 plus y into e2 plus z into e3 because they are not given any defined function here. Because of that, we are writing like that. From the definition of linear transformation, the sum of the linear transformation is nothing but y into t of e2 plus z into t of e3 equal to 0 vector. Now, you already know that you already given what is my t of e1. What is my t of e1 is 0, 1, 0, 2. And also they given what is t of e2. What is t of e2 here? 0, 1, 1, 0. What is my t of e3 value they given very clearly? Is 0, 1, minus 1, 4 equal to 0. You simplify that. Means add the first component. Before going to add multiplied by 0, 0, 0. Therefore, first component is 0. What about the second component? X plus y plus z. X plus y plus z. What about the next component here? Third component 0 plus y minus z. Y minus z. Okay. Comma. What's the last one? 2x 0 4z. 2x plus 4z. 0 can also be written as 0 vector can also be written how many components? Because 0 vector comes in 4 domain. What's the dimension is 4. 2 vectors are equal. The corresponding components are equal. That implies 0 equal to 0. X plus y plus z must be equal to 0. So 0. Y minus z equal to 0. And then 2x plus 4z must be equal to 0. From y minus z equal to 0, what we get? Y is equal to z. Y is equal to z. Are you clear? I think everyone is clear. That implies, what we get actually? 2x is equal to minus 4z. That implies what is my x? X is what actually? Minus 2z. Yeah, x and y at express in terms of z. Right? Sorry, x and y at express in terms of z. Therefore, what we get here, therefore, n of t is nothing but, please try to understand here, what is my x in terms of z? Actually, n of t having a vector like x, y, x comma y comma z. What is my x? Minus 2z, comma. What is my y? Z. Z is z itself. Such that z belongs to set of real numbers. This is my null space. This is my null space. Please try to understand. This is my null space. After this step, what's the dimension? That is nullity. Dimension of null space is nothing but nullity of linear transformation. What's the next dimension is 1. Yes, we saw just a few minutes before one problem, x like that. Minus 2, don't confuse, let's say some scalar value, that's all. Everywhere they have inside z. What's say, this is my null space, then what's the dimension of null space is 1. Therefore, rank of t plus nullity of t, what we get actually? 2 plus 1. What is 2 plus 1? 3. Is nothing but dimension of domain. What is domain is V3 of R. Yes, is satisfied. Therefore, is satisfied, is verified, satisfied is theorem. Rank nullity theorem. Suppose rank of t plus nullity of t is not equal to dimension of domain. What is my dimension of domain is V3 of R. Then we say that is not satisfied, rank nullity theorem. It's not satisfied means you maybe did somewhere mistake to find out rank and nullity. You check it out and do it. Thank you very much for listening that. I am going to take in the next class rank nullity theorem. I am going to explain, even though it's not yet given with you question paper, please, it's very important. I am going to explain very easiest way how I have to write the proof of that result, and also take another 1 or 2 different type of problems. That's it. Next class is my last class for this chapter. Thank you very much. If you have any doubt, anything, you please give a comments where in video upload, or maybe I have to give a in WhatsApp. We anyway have a group. Thank you very much.